Fantastic. Well, again, thanks to everybody who came here to join us. I'm Omar, the co-founder and CEO of Weavechain, and we are privileged today to have Daniel Uribe from GenoBank here to talk to us about all the magnificent things they're doing with self-sovereign genomic data, and really, I think, giving people the tools to understand themselves better in a modern world. But Daniel, why don't I let you introduce yourself for everybody here?
Thank you very much, Omar. It's a pleasure to be here with you today and with your team. And yeah, my name is Daniel Uribe. I am the CEO and co-founder of genobank.io. And we've been trying since 2018 to promote the use of Web3 technology and more specific NFTs to allow people own and control their biosamples and their biosample derived data sets, right? So that's basically the main objective of our project.
Oh, it's beautiful. And if I remember correctly, you guys were actually like part of the NFT standard originally when you were designing the bio NFTs. Isn't that right?
Well, we had also the privilege to work with William and Triken. He's a very nice guy. We became friends in 2019 because I asked him, I mean, I met him by saying, hey, well, would you help us to design a new ERC for DNA data? And after months of researching together the topic, we came with the framework that the biosample from the biosample data and human data is only subject to regulations in terms of the data privacy laws. So we proposed a framework that we called the biosample permission token with using NFTs or biosample consent token. And let's say we baptized it as the bio NFT in 2019. So, but it's based on the ERC 721 standard with two main differences. Because the ERC 721 was to track ownership and track ownership when I transmit ownership, right, of a unique asset. In our case, is to track permissions. Ownership will always be locked into the biosample provider or biosample owner, in this case, most of the time, the patient. So that's one of the main differences. The other difference is that is based on the GDPR framework. So it'll give you right to consent, right to own your data, right to edit your data, and the fourth one is right to erase your data or to revoke the consent. So that's in a highlight, right? Those are the characteristics that William and I are proposing. Yeah,
I think that's actually how we like first bonded. I remember we were at DeSci SF and you came and spoke with us. And I die on that GDPR hill all the time. I'm like, look, this is actually the right way to handle people's data. You should be giving them ownership rights and the right to delete. And that's a real problem if you're going and putting healthcare data on public Web3, whether that's inside of smart contracts, on the public version of IPFS or in an NFT. Once it's out there, it's out there. You can never take that back. And, even if you can encrypt it, you can't go and say that like that 2023 encryption is going to last 50 years from now. And so, quantum computing comes along and there's some real problems there. But, it's funny that the community of people that are really sort of cognizant of those data privacy rights, it's actually quite small. Especially in a space like Web3 that's less focused on like things that really relate to more enterprise software and really trying to pioneer these things. But like when I heard you talking about this at DeSci I was just like, oh my gosh, I'm so excited. Somebody who speaks my language is really into these things. Daniel, maybe could you walk us through, I can pull up on screen genobank.io. Could you walk us through what the process looks like today for a user?
Of course. Thank you very much. So basically, I mean, I have in my hands the typical saliva kit. Sorry, thank you for returning the camera. So I have a typical spit kit, right? Many of people who has already participated with 23andMe or Ancestry DNA, all these type of companies will recognize these two, right? So you put your saliva here, and then what we have here is what we call the QR code of a pre-NFT, right? This is a pre-bio NFT because this QR code already has two things. It has the cryptographic identity of the laboratory, which will receive and process your sample. And it also has the unique serial number from this biosample too, right? So in this case, I think, well, it starts with 01, but the thing is that, no, with 55, sorry. But the main thing is that we are trying to give identity to these two using NFTs in a public blockchain. We are not trying to identify the person. We are trying to give more power, more control to the person who scans the QR code and links a wallet. It could be an existing one, or you can create a new one for just privacy preserving. And then we will give you one of these cards as well. This is an NFC card that contains or stores a private key, and in conjunction, you can use your phone. You can tap your phone, and you can sign and authorize all the transactions using basically an EIP55 signature or address using this type of technology. Or if you prefer, I mean, we have the old version, which will allow you, this is a card where you can write down your 12 words and control your vault, because every single kit from that is under our protocol will have access to its own decentralized vault powered by Weavechain. So this is where we are very honored to participate and be partnering with you and your team.
No, trust me, Daniel, the honor is mine. You know, we are humble infrastructure data plumbers. You're the one that's actually going and changing things, because I think, you know, the common saying for Web3 is that, you know, Web1 was read, Web2 was read write, Web3 is read write own. And you are enabling this ownership of your data, right? And you're doing it in a way that's compliant, and that lets people be using these tools for really cooler ways to be providing consent to others. And I just love that. But maybe we could sort of think from a more macro level for a second.
Yes.
Like, what would you say like DeSci is to you? Like, and you, what sort of specific areas do you think that GenoBank is focused on solving?
I believe that's the core question that I think is we are leaving, right? Because in essence, I think science was already decentralized, or its nature is decentralized. The thing is that the movement in and all we are like, I consider myself part of the movement, of course, is because the internet, the Web2, as we are still living on it, is basically a corporate owned internet, right? And this corporate owned internet, one of the main characteristics is that they use personal and public data as a competitive advantage, creating silos, right? So these silos that basically are their assets contain our data, and it is not the best solution for scaling science, because there are interests that are not aligned necessarily with patients or independent researchers or small and medium labs, right? So this model favors the big ones, right? Because they have more resources, and therefore they have more capacity to hoard data and to become more and more, let's say, asymmetric in terms of the power they can harness. That being said, decentralized science, in there's many definitions. What for me is how you empower the individuals, how do you empower the families, how you empower the independent researcher or the small laboratories to have a more to have more equity, to have more opportunity to have important and meaningful discoveries, right, together. So now we are in the era of families coming together, forming a DAO, for instance, a decentralized autonomous organizations, and these families like myself could have a rare disease on the family, become part of the DAO, pool resources or put resources there, and then the DAO could now partner with researchers to make or collaborate to make important or meaningful discoveries on hyper focusing on just one disease, for instance, right? In our case is Glanzmann thrombocythemia. It could be rare blood diseases, for instance. But what I'm trying to tell you is like now you don't need like these necessarily big pharma companies, or at least in theory. I mean, we are still building, as you were saying, the pipelines. But for GenoBank, the step number one is to separate, right? To give the patients control over the data. We have plenty in our dish just with that task. And what I mean is our thesis is that we need to begin with the data that is derived from the biosamples, all the biomarkers, clinical laboratories, genetic laboratories, and so on and so forth. Is just the data that you use every day to start use a clinical path, right? Or some discoveries. But what I'm trying to tell you is like even just with that task, for me, decentralized science today is about separating the data, the private data that belongs to the patients from the corporate data that maybe the AI that you're training and so on and so forth. But there's got to be a very clear, transparent frontier or border between patients' data and companies' IP.
It's so interesting because like Web3 is a lot about shifting the incentives model. I was trying to see if I could go and pull up a slide over here that was from Andreessen Horowitz that was showing in Web2 you're really trying to go and shift all of the value to investors and builders, and
Right.
very little of that is actually going to the users that are providing their data for these economies. That's not a good thing, right? That's not something that you actually want to be having in a fair ecosystem. And DeSci oftentimes is touted as saying we're going to go and give science back to the people the way that it always meant to be done. And it's very cool that you can sort of have that long-term perspective and still understand that step one is at least giving people ownership of the data, right? We need to work our way to that sort of utopian vision in order to be able to, like, let's say, make tractable progress. And I was finally able to pick out that slide over here. Let me see if I can share that one more time.
No,
Here's how we're going to shift that value share, right? Not just giving value to the investors and builders, but giving it to users and creators as a healthier way to make everybody thrive together.
yes, exactly. In a conference not long ago in San Diego, I was telling the audience we want patients not to be data targets, but to be data partners, right?
Oh, beautiful.
Yeah, and the crowd also loved like see, yeah, I mean because it's a dignity kind of topic, right? And also scalability is more scalable. Your model is more scalable if you are equitable, right? And yeah, so this is the future. And specifically talking about genetic testing companies, we are already seeing the decay on that people is refusing to participate with centralized genetic testing companies because they have privacy and data ownership concerns. So it's already there. I mean, they are not scaling anymore.
It's just it's not the way that the future is going to really happen. So maybe we could shift gears really quickly and talk about the work that we've done together, and then
Please.
we can sort of talk about your vision of how we're going to go and iterate towards that future. So I'll start with a brief overview of Weavechain's humble role as the infrastructure in this ecosystem, and then maybe we can actually show them the Genoverse, and then take the conversation from there. So what we do at Weavechain is say that you can go and build a Web3 data app. And the idea is that if you start with the application stack that you currently know and love, you can actually build a really nice performant app in a cool way, have the Weavechain node on-prem connected to that, and then let these applications participate in these data economies that are providing interesting incentives, or helping people navigate things like these bio NFTs, and then also make the data verifiable. So, whenever you hear proof of identity or proof of lineage, we're saying that the same way you can go and see activity on a block explorer, you should be able to know who's accessing your genetic data and how, right? And see that lineage. So for the Genoverse, we started with this idea of how we're going to go and navigate the data and give it these nice security properties. And we're building this first version with a GenoBank versus the traditional model, which is the data stewards like hospitals or other providers are going to be the only people that have it. And I'm really excited for what we're going to work on next, which is this GenoVault that will allow this true self-sovereignty of data. But then we need to go and enable Web3 secure access to it by utilizing that bio NFT that comes from GenoBank to go and give consent over here and tie it to wallets, these cryptographic entities that really can't be spoofed easily. Then we want to go and enable confidential computing practices so that even if we are going and having the Genoverse providing the ability to analyze that data, that it shouldn't be able to see it, right? Technology has moved past that, where you can have the data stored locally and nobody should be able to touch it, even if they want to provide you value for that data. Then we go and give it that data lineage by anchoring it to the blockchain. And the hope is that you're going to be able to actually derive more value out of your data in this Web3 future by utilizing the bioinformatics marketplace we had to go and purchase studies using all these nice security features. And I think a very cool long-term vision is that when your data is connected to the Genoverse, that you should actually be able to go and earn money by saying, I am willing to give my consent to another researcher that's doing work that I agree with, as long as they're willing to compensate me fairly for that access. So, this is sort of the high-level vision. And the functional product is something that I'm really proud of us having built together. So here is the Genoverse, and I'm currently connected with my wallet. And what do you think, Daniel? Should we go into longevity first over here?
Please. That's one of the most interesting topics right now, longevity, right?
Oh, for sure. So over here in the Genoverse, what it enables me to do is to actually purchase studies on my own genetic data, which I may be hosting in a self-sovereign capacity, and have that study run in a way that fully preserves my privacy. So I have already purchased this report, but when I'm going to go and access it over here, this is actually showing us my genetic data. So unfortunately, everybody watching this webinar will know that I have a slight risk of worse aging than the average person, but I do see a lot of positive things over here as well. And I'm proud to say that my abuelito, he lived to the lovely age of 94. So I think there's a decent chance that I could make it to 100 myself. Now, this calculation happened in a way that was fully self-sovereign, right? There's no breach of privacy in this process, but I can go and benefit from this data that's against my data set. And I think one of the cooler things that we did early days was say, you don't wonder if you're going on eBay or YouTube, like it's sort of like buyer beware kind of thing. But there was a study on Alzheimer's that was actually, I think, taken off of 23andMe, even though the source code here is completely open source. And, there was real science that went into this. And so we went and enabled it so that I could go and actually understand whether I had this Alzheimer's risk. And we always say, you want to go and take this data, give it to a genetic counselor if you're going to make any decisions, but make this available to individuals. Now, Daniel, you had one amazing idea that extended this platform way further than I had possibly imagined. Can you talk about this little icon in the up left over here?
Thank you, Omar. So the main idea, as you were saying, of this platform is to show the capabilities of having these what we call personal genetic data lockers, right? Or your GenoVault, or I mean, these vaults are becoming really, really popular now. That's a good thing for personal information in general. So one of the benefits of having your data secure, as you were saying, is now by using Weavechain technology, we can provide computational analysis and privacy preserving computational analysis. So this feature that we thought is, why don't we connect to ChatGPT, create a conversation with ChatGPT regarding any risk associated with any specific disease. Like for instance, if we can do a demo like saying, hey, what is my risk associated with maybe diabetes, if you're okay with
Sure.
it. And please provide the the name SNPs, SNPs, please. So ChatGPT will know that it's genetic related, right? So what is my risk associated with diabetes based on my SNPs, right? Based on my SNPs, that would be. So we're gonna list some suggestions of how to exploit these conversations better. But today you just need to tell ChatGPT that is based on your SNPs. So what is happening under the hood is we analyze the conversation with ChatGPT and we filter all the SNPs that usually it
Oh,
brings, right? So
let's try one more time.
okay,
I'm going to go and give it a simpler one because I know we add some of this context over here on the usual bits.
okay.
And just to confirm while we're chatting, ChatGPT is never seeing my data, correct?
Correct. Yeah, basically what we are looking here is when you generate a conversation, again, we filter the SNPs associated with the specific disease you're trying to find out, and we generate this privacy preserving query inside your vault, and we generate the report without looking into your data. So I think that the question was even easier just to say
Oh,
the
no,
disease.
I have increased risk for type 2 diabetes. Now the whole
And
internet knows.
right, and remember, this is a conversation, right? If there's something in the report you don't understand, you can take the results into your actual ChatGPT
Mm-hmm.
conversation direct, and you can literally ask, hey, I have a report from Genoverse. Actually, ChatGPT knows us, so if you can literally say, I have a report from genoverse.io that mentions this. Could you please explain to me so I can look for help, or what do you think I should do? And ChatGPT will tell you, and will explain like this in a more let's say less scientific kind
Mm.
of language, right? It'll explain to you what you should do. It'll probably recommend you to, as the same as we do, like, hey, just bring this report to a genetic counselor or with your geneticist of trust, right?
But I think what's so cool here is that ChatGPT is great about doing this early research where I can take our query and then go and compare it against something like Snipedia, which has a lot of this research already done, and then give us back a schema to compare against. And then it's the Genoverse that's actually handling comparing that schema against my data to ensure that there is zero breach of privacy here whatsoever in this data, but I can still get these results and learn something really interesting about myself. So, kudos, Daniel, on an amazing idea, and I'm excited to see how it's materialized. Just really briefly, what would you say excites you most about new large language learning models and AI like GPT-4 and ChatGPT when it comes to genomic data?
Well, it abstracts a lot of the work. So we are literally standing on the shoulders of giants in the
Mm.
genomic space, because all these, as you were showing to the audience, all these papers, peer reviewed, and so on and so forth. I mean, it's decades of research, and ChatGPT is literally doing what is, I think, the best, which is basically browsing or gathering all the information that it thinks that it model brings to that is relevant, right?
Mm.
And it saves basically weeks, I think, of research, of human time, in just seconds, and it'll tell you, hey, here's what I found. This is a super good start. I am not obviously a geneticist. I'm more into the cybersecurity and data privacy kind of, but I've been playing with Genoverse and .io, and I learned, for instance, that the atorvastatin that I am taking is not the ideal for me.
Wow.
I should be taking another molecule. Exactly, because I can ask, hey, what are the SNPs related to atorvastatin, which is more into the pharmacogenomics. And then it created a SNPs, and I've been comparing to the other existing drugs, and I just found out 8 additional drugs that are available that I was not aware. That doesn't mean I'm going to go and auto-medicate, but it generates a new conversation with my cardiologist, like saying,
Mm-hmm.
hey, what do you think about this? Because, my conversation with ChatGPT told me that based on my genetic makeup, this could be a better drug, right? It's more
Mm-hmm.
modern, so on. So you start reading, and this is just like the tip of the iceberg, because a little bit later in the conversation, we want to talk about the newborn
Yeah, I was
data.
just going to lead into that because
Yeah.
right now we're talking about increasing learning almost for ourselves, right? But now that we have data connected to the genome first and the ability to give consent for others to, let's say, utilize this as part of this beautiful mesh, what are interesting ways that you could see those data meshes adding value to the rest of society?
No, of course. And I think if we just talk to one case, I think the rest of humanity will fit right away. And I'm talking about the newborn sequencing era that is coming, that is really really here. Just on November last year, I was honored to participate in a conference. It was called by themselves like the first international conference for newborn sequencing, right?
Hmm.
It was a 2 day and more than 10 panels. And on every single panel, the question was, who is going to own the data of the babies? Who is going to control it? And it was consensus, like they must be there must be the parents, right? The parents is, or the custodians, or the guardians, right, of the baby. And I was like very honored to present what we have doing, this multi-signature wallet. We call it the family GenoBank, right? And it's family because it contains the data of the father, the mother, and the kid, or the child, the newborn in this case. And it's specifically to save lives. Now they presented a lot of advantage. Like just 5 years ago, even if you sequence a baby, there was 0 actionable items. Today, 18% of the newborns have an actionable item, an actionable treatment to improve the chances of surviving, the first most important objective, if their lives is under threat, or to have a super better or higher quality of life in their first months. No, so now in just 5 years, increasing from 0 to 18% of treatments, drugs, and so on and so forth. So we are learning really, really fast. And again, we are standing on the shoulders of the scientists in this case. But here's the catch. At the end of the day, GenoBank and all this effort with you and your team and Weavechain, what we want to do is, again, uh, give the ownership and control to parents over their newborn sequencing, and give some initial utility, which would allow them to look for the variants, right? The pathological variants. And I have if we have the time, I have a very personal anecdote to tell, just
Daniel,
by
unfortunately, we are
yeah.
at time. Lesson learned. We need at least twice this amount of time to continue this conversation because there are so many fun threads to deal on. But if I would wrap up, I would just say that my daughter is 3.5 herself. You may hear her in the background over there. But I would have loved the ability to go and have those insights when she was so young and to benefit from them. And I think this sort of connected world will let us leverage those benefits. But we start with self sovereignty. We start with making sure that it's done right, and then we go and figure out how we can benefit from it. But Daniel, it has been a true pleasure chatting with you today. Thank you for what you're doing. We're very excited to support you as well. And hopefully we can keep sharing more interesting stories in the near future.
Thank you, everybody, for joining us. Thank you, Omar, and your team. You've been amazing, and we please keep on touch. We're working very hard to bring a lot of innovation and collaboration. Thank you very much.
Beautiful. Thanks as well to the audience. And we'll post this online as soon as we can. Take care, everybody.
Take care.